Welcome to the next episode of VCF Breakroom Chats. I'm Shobhit Bhutani, Product Marketing Manager here at VCF Division in Broadcom. I'm the Product Marketing Lead for AI/ML and Gen AI, and I lead the messaging and positioning for AI/ML here at VMware. In this series, we bring VMware and partner experts to discuss VCF and associated technologies. These fabulous experts also share their backgrounds, industry trends, and general tips for IT technical experts and our customers. Today, I'm very excited to bring my friend Shawn Kelly, Principal Architect AI, VCF Division at Broadcom, in today's episode to discuss the newest release of VMware Private AI Foundation with NVIDIA. This is part two of what's new with the new release of VMware Private AI Foundation with NVIDIA, with the release of VCF 9.0 last month, June 17th. So welcome, Shawn.
Yeah, thanks, Shobhit. Glad to be here.
Wonderful. It's an exciting time today for Broadcom, right? From last month, right, when we released VCF 9.0. And Justin covered part one in this episode about the broad strokes of the release of VMware Private AI Foundation, this newest release with 9.0. And he focused more on infrastructure, simplify infrastructure management, and enable privacy and security category, right? Broad strokes categories of capabilities. Now, similarly, he touched streamlined model deployment category of capabilities that we launched. And this is what we're going to dig into this. So let's start from the highest level, Shawn. Can you please help us understand what does streamlined model deployment mean?
Yeah, so to me, it means we're really just making it easier, faster for organizations, for our customers to get their AI models into production. When it comes to VCF 9, we introduced a whole set of tools and services, and they're part of Private AI Foundation with NVIDIA. Things like the model store, model runtime, API gateway that we'll go over today, and those are the things to answer your question when we talk about streamlined model deployment. Those are the pieces that fit there, and then there's a few other pieces that are kind of part of that same set of services, including data indexing and retrieval, which I'll also cover a little bit of, and then the agent builder, which is something that last time Justin was able to give an overview of. But the bottom line here is we're just trying to provide or really reduce, I guess, the time to value for AI projects for our customers, make the path as smooth as possible, allow them to operationalize AI across the enterprise and the organization.
Excellent. So you really touched on some very interesting topics here, right? Like the fact that models need to be the management of models and the running of models and deployment of models, that can be hard for customers, right? So those are the broad strokes of this category of capabilities. Let's jump into the most important one, model runtime. Can you help us understand what that means?
Yeah, sure. The model runtime really provides a secure managed environment for running models as a service. This is a challenge that customers, I think, have, where it may be one thing to pull down an individual model from Hugging Face and deploy it as part of a POC, validate it. But it's an entirely different thing to do this in production, where you have multiple teams, multiple data sets, multiple projects. You're trying to scale from a handful of users in that POC to support many users and many apps. And so this is where being able to have a model runtime as a service is critical. It just makes it a lot easier to get these deployed, to manage them, to handle the scale overall. And that's what we're trying to accomplish here.
Excellent. Let's move on to the next important one, right? API gateway. Do you mind explaining how does that add value to enterprises? It's very, it's part of model runtime, but it kind of stands on as a very important capability by itself. Do you mind just sharing a little bit more on that?
Yeah, sure. So you're exactly right. It is part of the model runtime, and I think it's a key piece, and that's why we spend a little bit extra time speaking to it separately. It provides a way to expose the models to those apps and users that I mentioned in a safe and secure way. It's kind of a centralized entry point, provides authentication, authorization, the traffic management for all the model endpoints. allows us to scale up and down as required, to be able to update the models behind it, and to load balance as well, right? With that incoming traffic. And there are cases that once we scale things up and we have multiple replicas of a model to be able to handle the traffic, we need to load balance across those as well. So it gives us, fine grained control over the models, the enforcement of security, the policies, the usage, and everything we need beyond just deploying a model in an endpoint.
Excellent. So let's jump into the last one, right? Before we get into the super cool demos, right?
Sure.
It, why, data indexing and retrieval service, why is that critical?
Yeah. So this is another challenge that our customers have had. They have data in all of these various places. Usually, this is what we call unstructured data. Think of it as PDFs and docs and PowerPoints and all of those types of things. And they're in many different places. They're in SharePoint, they're in Google Drives. We also have a lot of knowledge, and we do this internally at VMware. We have a ton of knowledge in Confluence in various pages. And so, how do you easily gather all that data and team it up with a large language model so that you can ask natural language questions against it? That's been the challenge. The customers say, yeah, you do a great job in the infrastructure. How do we handle all this data? And so we've solved that problem with data indexing and retrieval. It allows our organizations to be able to identify these different data sources, SharePoint, Confluence, really any S3 compatible storage, and build these into what we call knowledge bases, where we can index that data, we can transform it into vector embeddings, and make it available to a large language model to connect to, so that our customers do have the ability to reach into all their private proprietary data on premises in a secure way, but use that with a large language model so we can ask all the right questions against it and get answers quickly.
Fantastic. Now let's jump into the cool stuff, the demo.
Yeah, sure. Let me share out my desktop here and let's get going. So here I am in VMware Cloud Foundation Automation. This is the front end we're using for the model runtime service, a section we call Private AI Services. And I'm just going to create a new model endpoint. And so this is actually a really easy set of forms. You'll see it collapse up as I go. I think that the UI team did a great job. It's super easy to use. We start just with where's the model located. In our case, it's in Harbor, which we're using as a model store. We can select a type of secret. We'll use the Harbor pool in this case and give a description. And from there, we just hit next and move to the next section in the sequence. Here we're going to provide an endpoint specification that consists primarily of a routing name and display name. The display name by default is the same as the routing name. And then the model type. We have two types of models, generally speaking. So when you're thinking of something we have like here with Mistral or Llama is another common one that you would find as part of a chatbot. These are completion models. The other type of model, which I'll touch on a little bit more, is the embeddings model. This is the model that takes all those documents and takes the chunks of data, turns them into vector embeddings, and gets them into a vector database. But yeah, we'll go with a completions model here, and then the engine that we'll use behind that is VLLM, the open source version of that. And for both of these engines, we provide the ability to use flags, arguments, overrides, things like that as well, if required. I'm not going to get into that here. We'll just move on. And that brings us to the next set, which is what resources do we need behind this in order to deploy it? And for some models, you can get away with CPU only. But in this case, for a Mistral model like this, we are going to need GPU to back it. And so we'll define this via a VM class. And you can think of VM classes as our method of defining t-shirt sizes for our resources. So in the case of an A100 medium, that's the name of the VM class, we'll have 16 virtual GPUs behind it, 48 gigs of RAM, and then an A100, an NVIDIA A100 GPU with 40 gigs of RAM. And then we'll define a storage class as well. And that's it. We review all the data, we make sure that everything is good to go. On the right-hand side, you can see that the Kubernetes resource, the YAML, has been written as we've walked through, and now we're ready to deploy. And so this only takes a few seconds in the demo. In reality, it takes several minutes, but that's okay. I think, you know, when you think of what we're doing here, it really only took a few minutes to deploy the model within a Kubernetes cluster. It's behind an OpenAI API compatible gateway. We have authentication and we have authentication, we have load balancing, we have the ability to scale this up and down to meet demand. We have all the things that you would expect for enterprise grade deployment, right? For full production deployment in just a few minutes. So I think that's a pretty great capability for the model runtime.
Excellent.
Now let me move to the data indexing and retrieval. And this actually takes us out of VCF automation and into a separate interface. The thinking along those lines is that when it comes to resources, that's going to reside with the infrastructure admins. But some of the things that we're talking about now are going to reside with the data scientists. So we wanted to give them their own UI. And this is what it looks like. And we'll start by creating a new knowledge base. Again, a simple UI where we can insert a name, a description if we want, and then choose what is this knowledge base going to consist of? And we have options of data sources, or I'm going to use, for simplicity, just local files. But if I were to use the data source, as I mentioned before, this could be Confluence pages, any S3 compatible storage. It could be SharePoint, Google Drive, things like that. So a lot of flexibility to be able to go into different parts of your environment, identify the documents, and you can do this in a very granular way, specific pages you want or specific files within those shares. And you can identify them as part of a knowledge base. In this case, I'm just going to do it with some local files. And so step one is I created the knowledge base. Step two is I'm going to put some details, submit some details in here about how we're going to chunk and embed the data, starting with which model do we want to use, which of the embedding models that have been deployed via the model runtime would I want to use. We're going to use the sentences for the text splitting, and then chunk size and token overlap. So chunk size refers to the number of tokens. You can think of tokens as words or subwords, but I usually think of them as words. So this is just the number of words in it that are going to be kind of captured at once in a segment. That defines a chunk. And then the overlap is the number of, or really the percentage of those words that winds up being okay to overlap between the two, and that helps provide better context. So here we'll use 200 for the chunk size, and then we'll just use 30 for the token overlap. That's about 15%. 10 to 20% is the normal overlap. We'll save those settings, and now it's just about adding the files. These are the different types of files that we have here. So PDF, HTML, Markdown, PowerPoint, documents, text, and CSV. And we'll select a file, and then it's really that easy to just upload a file. I just did one. It's a fairly large file, but it could be multiple files from a laptop like I'm doing here, or of course, many files throughout the environment as I already called out. And that's it. So now we have a knowledge base that can then be consumed alongside the model runtime as you go to build an agent. So that'll be the next step that that I believe Justin already covered in a previous section, where he takes this data and a model runtime that's deployed, brings them all together to create an AI agent that can be leveraged by teams in the environment to ask questions on internal private proprietary data.
Excellent. Thank you. That really helps, Shawn. And like you explained, right? That kind of rounds out the entire journey, right? Of deploying, from data indexing to setting up model runtime, and then finally deploying it through an AI agent, right?
Yeah,
So
exactly.
Yep.
You're exactly right, and I think what really impressed me the first time I saw this is we really are going from pulling down a model, deploying it in a runtime, finding our data, and then deploying an agent in a matter of minutes. So the ability to do that so quickly and iterate on it to make sure you have it exactly right before deploying it in production, and then when you do deploy it in production, to have it actually being load balanced and having all of the lifecycle management operations you would expect behind it, I think that's really powerful, and I think we've done it in a pretty easy way. So I was super impressed when I saw this for the first time, and I hope everyone else likes it as well.
Absolutely. And with that, we're coming to a close of this episode. Thanks so much today for joining me, Shawn.
Thanks for having me, Shobit.
Wonderful. Really enjoyed the conversation. And with that, we're coming to an end of this episode. If you like this episode, join in for the next time. This is your host, Shobhit Bhutani, signing off. Have a fabulous day, evening, night, and week. Bye bye till next time.
Thanks, everyone.